Hello students, in this class we will discuss about the earthing. So generally you will hear the word earthing. So whenever we are touching our electrical appliances like our TV or refrigerator and stabilizer all etc things, sometimes we will get the shock. The reason for the shocking is, look at here, just this is the motor, some any motor. Generally this is a three-phase motor. We are giving a three-phase supply. Three-phase supply is given to the motor and motor will work. Sometimes a sometimes a live phase will touch the motor body. So motor is the metal. Metal has the property of conducting the power. That's why when we are touching this, automatically we will get the shock. Touching means what happened? If there is no earthing, if we touch here, for example, a human is touching this, then what happened? If there is no, then the current will be flow through the human and human to the ground. Ground is always the neutral point. All ground means our earth will always zero potential. This is some 440 volts and this is zero potential. The current will be flow through our body. Whenever current will be flow through our body, we will get the shock. That's why in order to avoid this, we have to give the earthing. Earthing means these metal body and remaining outer parts are connected to a conductor to the earth. Then whenever a phase current is touched to the metal body, through this metal body it will flow through the earth ground. Then the total current will be flow through this ground. Whenever we will touch, we get a small slight shock, not bigger shock. We can save our life by using this earthing. Earthing means our electrical appliances outer frames and inner body is connected to a earth through a conductor. Then this process is called as earthing. So by this earthing we will save our lives and we will avoid the electric shocks. Yes, now you will understand what is earthing. So we will look at each and every point, then you will understand very clearly about earthing. An electrical equipment or appliance is said to be earthed if its outer frame and its other parts are not carrying any current or connected to the earth so as to attain the nearly zero potential as possible. So whenever it connected to the ground, automatically the complete current will be flow through the ground. It not flow through our body. Then that is the reason we will not get the shocking. If there is no earthing, automatically the current will be flow through our body, then our body will damage. In practice, all equipments and machinery as well as electric poles, towers, neutral wires, etc. all are earthed. If you observe clearly, the earthing will be each and everything. This is the machine, and electric poles also consisting of the some earthing. Sometimes the before olden days the electric poles are made with the iron. That time when we touch, sometimes we will get that. Whenever face touch it, we will get that. That's why that is also earthed. And towers and neutral wire also earthed. The purpose of earthing is to ensure that all parts of the system other than live parts are earthed potential at all times. Live parts means these parts, this A phase and B phase, So for example, if this is earthed, what happens? If this is earthing, one phase is earthed, the earthing to the ground, then what happens? The complete current will be flow through only ground only. Then there is no power entering into the motor. The motor will not working proper. That's why live phases doesn't give the earthing, because if you give the earth, the total power will be travel to this. Then live parts are maintained at the earth potential at all times. Understand? Right. Next, objective of earthing. The main intention of the earthing is, first, the main objective of earthing is to provide safety operation. Understand? It will give the safety operation. Second, another objective of the earthing is to save the conducting material. How you can save the conducting material? It will avoid the short circuit and the conducting material will be saved here. Third, it also helps the protecting high-rise building from the atmosphere lighting. It is also protecting the high-rise buildings. We will get the sometimes we will get the lighting here. A fork or metal rod or thick wire called lightning conductor. So generally that is made with the a fork metal rod or thick wire is used for the lightning conductor. Sticks out from the top of the building, chimney, tower, etc. So generally this is we will put in the building top. That's why it will absorb the lighting. Its other and buried deep the ground whenever lightning occurs. The electricity passes directly from the top of the lightning conductor to the earth, thereby protecting the building from any damage. So look at here. So we have some building. Generally we have one building here. This is one building. Generally, the top of the building we will put a lighting arrestor. What happens whenever it gets the lighting, it will take the lighting and it will be flow into the ground, buried ground. Then the complete lighting will be the high amount of current, millions of current will be flowing through the ground. Then this building will be safe. This building will be safe. So this is also earthing. Lighting arrestor process is also same as earthing. Same as earthing. This process is also same as the earthing. Understand? Yes. Lighting arrestor process is same as earthing. So that's why we will save any building or chimney. Chimneys means generally if you observe the thermal power stations, these are looking like this. These are called chimneys. Looking like this. Towers. So all are consisting of the lighting arrest to avoid the lightning. Next, methods of earthing. So in our electrical system, we have generally more number of methods. We will discuss each and every method. First method, earthing should be done in a way so that short circuit and earth loop impedance is low enough to pass 3 times the current if fuses are used, 1.5 times current if the MCB is used. Simply, the most important thing is when the current flow is possible, whenever the earth loop impedance is low, the earth loop impedance is low. How much it is? That low impedance is the current should be 3 times of current. It will take the 3 times of current when fuses are used. That means the impedance, earth loop impedance Z by 3. Then the current will become 3 times. Understand? And 1.5 times if the current MCB used. Then the impedance must be less than 1.5 times. And current will 1.5 times of current will flow. So we will decreasing the impedance. What happens when we will decreasing the impedance? Look at here. So it is connected to ground. This is the earthing. Then earth loop impedance means impedance between this point and this ground point. This point and this ground point. This will be low. Whenever it will be low, the current will doesn't flow like this. Current will be entering like this from the metal body. From the metal body. So that is the process we are using here. The impedance will be decreased here. Whenever impedance is decreased, automatically current will be increases. Next, the metalwork should be look at it. The metalwork should be solidly earthed without using any switch or fuse in the circuit. We doesn't use any switch or fuse. Directly it connected to ground. For effective earthing, the resistance offered by the earth electrode along with the soil which electrode embedded should be quite low. The resistance will be low simply. Earth electrode means, so we are connected to ground, that point is called earth electrode. That earth electrode resistance will be low. Galvanized iron Gi or copper is used to make an earth electrode. So in order to make the earth electrode, which type of material we are using? One is galvanized iron and another one is copper. These are the two materials generally we are used for earthing. Generally we are used for earthing. Which material? This is very important. One is galvanized iron, another one is the copper. These are the materials. Why we are using? These are high conducting materials. High conducting materials, galvanized iron or copper. Why we are using? High conducting property materials. Whenever high conducting properties are there, then automatically it will be grounded. To make an earth electrode. To make the earth electrode. Next. There are different types of earthing methods are used. First, strip or wire earthing. Second, rod earthing. Third, pipe earthing. Fourth, plate earthing. So these are the different types of earthing methods. 4 methods. In this, pipe and plate earthing are commonly used. Pipe earthing and the plate earthing very commonly used methods. So we will discuss each and every method. Next. First, strip or wire earthing. The first is the strip or wire earthing. Look at the earth wire is look like this is the earth wire. Earth wire is looking like this. So by that metal body too. So before that it has a metal body and we have a ground here. In this system of earthing, strip electrodes of cross sectional not less than the 25 mm, 1.6 mm. 25 mm means the this is the width and 1.6 mm is the thickness. So 25 mm is the generally this is the width. We can call it as the width, and 1.6 mm is the thickness. 1.6 mm is the thickness. So this length depends on the material. Copper. If it is copper, this is for the copper. We have to use this metal. And 25 mm, 4 mm galvanized iron. If the galvanized iron is there, these calculations must be used. Or steel, galvanized iron or steel, both are same. Are buried in horizontal trenches of minimum depth of 5 meter. So it is from the ground. If it is a ground, we have to use this buried into the 0.5 meters length. 0.5 meters length. Yes. Understand? But look at here. Look at here. 25 we are using. Look at here. So here for the copper we are using 25 mm, 1.6 mm. But here for galvanized iron 25 mm, 4 mm. This length is this thickness is more because compared with the galvanized iron or steel, copper has more conducting properties. That's why we are using the less material. Understand? Right. But for the both, the length must be 0.5 meter. If round conductors are used, the cross-sectional area shall not be smaller than 3 mm square. What is cross-sectional area? Cross-sectional area means if the round conductors, if we are using the round conductors, this is the round conductor. So this cross-sectional area must be, cross-sectional formula is pi r square, that must be 3 mm square, not less than 3 mm square. If copper is used for the copper, 6 mm square for galvanized iron or steel used. If we are using galvanized iron or steel, we have to use that thing. Next, the length of the buried conductor shall be sufficient to give the required earth resistance. So the required earth resistance will be give by this earth resistance. It shall however be not less than 1.5 meter. So completely it is must be 1.5 meters, complete 1.5 meter, but 0.5 meters is less. 0.5 meters must be in the buried. Okay na? This is 1.5. This is generally this is the complete length is from that point to this is a 1 meter, and this is 0.5 meter. Complete is 1.5 meter, but in the ground it must be 0.5 meters. Okay, this type of earthing is used to places which have rocky soil, earth bed, because at such places excavation work of plate earthing is difficult. Generally plate earthing is preferred wherever the plate earthing means rocky soil. Whenever the rocks are there, there must be some difficult handling, rocky soil is there. In that case we are using this strip or wire earthing, but it is very less useful. It is very less useful. So this is about the strip wire. Next, rod earthing. Name itself, in place of this we will use the rod earthing. Name itself, look at here, we are using a rod as our earth material. Look at here, this is the rod and this is the ground. This rod will be created like this, and earthing lead means this earthing wire is connected to this point and this will be grounded, and this is the earth rod. This is electrolyte roots. Electrolytes will be used here. So if you observe this rod is look like this. In this top point is called steel driving cop, this point, and copper earth rod, this is called copper earth rod. The inside we have a rod is there, this is the dowel and the copper earth rod. Next, last point is hardened steel tip. This is called hardened steel tip. Generally this length will be 4 feet 1.2. This is the 4 feet 1.2, and this is also 4 feet. Like this we have to use, right? Look at here, 1.2 meter, 4 feet, and this is the 1.21 meter. This is also 1.2 meter. The earthing will given to this rod. This rod will, whenever the short circuit of the metal is there or outer part, then automatically the current will be flow through this rod and this will be entering into the ground. Then the machine will be safety. In this type of earthing, 12.5 mm diameter solid rods. This diameter is 12.5 mm copper and 16 mm diameter solid rods galvanized iron. So per copper always less, for galvanized iron or steel it is more. Or hollow section 25 mm GI pipes of length not less than the 2.5 meters. If it is hollow, then you have to use the 25 mm. Hollow means it is there is a space in the rod. Or driven vertically into the earth either manually or pneumatic hammer. By using the hammer or we have to put vertical. This is the vertical model. In order to increase the embedded length of the electrodes under the ground, which is sometimes necessary to reduce the earth resistance to desired value. Sometimes in order to decrease the more resistance, to increase the current rating, we have to reduce the earth resistance. We can increase this length. More than one rod sections are hammered one above the other. Look at here, we can use 2 rods here. We can increase the rod sections. Whenever we increasing these rod sections, automatically impedance will be decreased, resistance will be decreased, automatically the rating will be increases. More much fault current will be grounded. Next, the system of earthing is suitable for areas which are sandy in character. Wherever the sand is there it is useful. The system of earthing is very cheap as no excavation work is involved. Directly we are using the rod, that's why there is no excavation work, that's why it is very cheap. It is useful in sand areas and it is very cheap. Next earthing is the pipe earthing. Pipe earthing. We are using pipe type of model, then it is useful. Look at here. This is the pipe earthing. In this is the ground and this is the pipe earthing point. A wire is given here. The GI pipe is used and GI pipe is extended like this. We are putting some holes here, and after that for this particular area we have to use ground. Coal is used for a particular time and salt layer is used above the coal. Again we are using the coal, again the salt layer, and this is the GI pipe thing. So one by one, first coal, again salt, first coal, again salt in particular lengths, and we have to use a tunnel. Look at here, this is the tunnel. In this tunnel we can pour a water to maintain its more conductivity, to maintain the more conductivity, right? Okay, a GI pipe with few holes at its lower end is buried to depth not less than 2 meters, at least 0.6 meters away from the foundation of any building. This length is must be 2 meters. It must be 2 meters. This point to this point 2 meters and 0.6 meters away from the foundation. Normally the size of the pipe is either 2 meters long or 38 mm diameter or 1.37 meter long and 51 meters diameters. However, for the dry and rocky side we use longer pipes. Understand? So this is the length and this is the diameter we have to use. Alternate layers of the common salt and charcoal have thickness of 30 mm and 80 mm respectively. We are using first salt and charcoal for 30 mm and 80 mm like that. To maintain good conductivity of the soil, an arrangement is made pouring water into the earth pit surrounding at the earth electrode. So we have to pour the water. To maintain the conductivity, because water having the more conducting property. So that's why we are getting shock whenever a short circuit occurs there. This is specially needed during summer. In the summer we require this. This pipe has much larger contact area with soil. Generally the pipe here, look at here, this pipe has more contact area compared with the rod. It can handle the large leakage currents than the plate earthing of the same electrode size. So we are not discussing about the plate earthing, but compared with the plate earthing, this is the handling very large leakage currents. Next, the earth wire made of copper is tightly fastened to the earth electrode by means of the nut and bolt. So it is connected to the nut or bolt. We have earth electrode is there. We are connecting to that. Understand? This is about the pipe earthing. How you can remember this? A simple thing. This construction is look like a pipe, and we have a more arrangement by using the coal and the salt, coal salt. We have a separate tunnel for pouring the water. This is very good applicable earthing, and compare with it is very useful the plate earthing. Next, fourth earthing is the plate earthing. Name itself, plate earthing. Look at here. So same earthing, plate earthing. If you observe here, we have to use the same tunnel, and this tunnel is connected to a pipe. Leave that pipe, and this is a plate. Look at here. This is the one plate. The yellow color is the plate. The plate is called earth electrode. Why it is called earth electrode? From this point to this point, the leakage current is entering from this earth electrode only, and this earth lead, from this point the leakage current will be, or short circuit current will be entering into this plate, and plate will be supplied to the ground, and this is the tunnel. From this point we can pour the water to maintain its conductivity, and there also we have used the sand is there, and salt, coal, all the elements are kept here, and it is vertically kept. This rod is 12.5 mm rod. This rod is 12.5 mm. This is the structure. Here the special, this is the pipe is there. By this pipe we can pour the water here. Okay, this is very important earthing, plate earthing. This is another common system of earthing. In the plate earthing, an earthing plate either copper dimensions. If the copper is there, 60 centimeters, 60 centimeters, 3 mm. That means 60 centimeters, 60 centimeters, 3 mm. This is the size of the, and GI dimensions are 60 centimeters, 60 centimeters, 6 mm. Is buried into the ground with its face vertical at depth not less than the 3 meters from the ground level. So it is from this point to this point 3 meters. The earth wire, GI wire for GI plate earthing, and copper wire for copper plate earthing. If you can use this plate copper or GI, anything. Is securely bolted to an earth plate with the help of a bolt. So look at here. This is GI wire. If it is a GI, this is we can take the GI plate and this is bolted. Look at here, by using the bolts we can attach this. Nut washer made of material that of earth plate. A small masonry brick wall enclosure with cast iron cover on the top. Look at here. This is the, by using the bricks we can make a tunnel here. We can make a tunnel here on the top, or an RCC pipe round the earth plate is provided to facilitate its identification. So it is useful for the identification and for carrying out periodical inspection and the test. It is used for the, from this point we can test this earth plating. It is working proper or not. We can test from this point, or we can, by using this we can pour the water to maintain the conductivity. Yes, plate earthing, simply it is a plate. This is the, don't confuse here, this point only, the conductor will be connected here, leakage current will be flow from this point. This pipe is for only testing, don't confuse here, this pipe is for only for testing. Okay, right. The copper plate and copper wire are usually not employed for grounding because of the higher cost. Generally we are not preferring the copper cost is very high, right. Next earthing is double earthing. So name itself we have to put the two wires for earthing. Look at here, this is the motor. Generally the power supply is come from motor this point to this point, and we are putting a one earthing wire and we have to use another earthing wire. But this earth connected to one plate and another plate. Any leakage for this thing, the leakage current will flow from this to earth electrode to ground. Here also it is useful. And what is the useful? If one is failed, it is applicable. That is the main reason, and it will, whenever we are using this parallel conductors, automatically the resistance decrement is very high. Whenever the resistance is high, the leakage current capability increases. Look at it, double earthing. For providing the better safety, it is advisable to provide two separate earth wires. More safety, from two separate earth electrodes connected to the same metallic body. Look at here, for same metallic body, two separate earth electrodes. Equipment at two different points. This is the 1 point and this is the 1 point. Is known as the double earthing. It's known as the double earthing. Second, double earthing is essential as per Indian electricity rule for metallic bodies of large rating equipment such as transformer, motors, etc. working at 400 volts and above. So double earthing generally preferable. Any motor, any machine is working at 400 volts and above. Double earthing is more preferable. Right. So this is about the double earthing. We have some advantages of double earthing. This is surety of safety. The first point is safety. Because at any time one earthing is ineffective, then another will provide the earth path to fault. Suppose here this wire is failed, earth wire is failed, then the leakage current will be flow to this electrode. The second, as two earth wires are in parallel, so effective resistance from the equipment to earth electrode is reduced. Whenever two parallel connectors are connected, the complete resistance will be decreases, then the more leakage current will be entering into this. So this is the importance of the double earthing. I think by following the class you will understand what is earthing, why we are doing these earthings. Generally in our every home, and office, we have to use the earthing, otherwise we will get the shock there. So any atmosphere condition, in order to maintain the safety, the earthing is most important. So we have these methods of earthing. In this method, generally rod and pipe and plate earthing are very famous. Pipe earthing as well as plate earthing, because the maintenance we are using, much maintenance we are using the coal and salt, all those materials that will provide more conducting to the materials. Okay, I think all of you understand this class. Thank you.